If you're watching this indoors right now, you're probably accelerating your brain's aging process. I know that sounds dramatic, but the 2025 data is absolutely terrifying. Per the latest estimates, over 1 billion people worldwide have 25-hydroxyvitamin D levels below 30 ng/ml. And here's the kicker, spending 93% of our time indoors correlates with higher dementia risk in major studies. The average American now spends exactly that much time away from natural sunlight, and new research shows this indoor lifestyle contributes to cognitive decline that's completely preventable. What I'm about to show you will make you question everything we've been told about staying safe indoors. The great indoor prison we built ourselves. Our ancestors survived ice ages, plagues, and famines by living under open skies. These people would look at us today and wonder how we managed to trap ourselves inside artificial boxes for 93% of our lives. That's not a typo. The average modern human spends less than 7% of their time outdoors. We've essentially become a species of voluntary prisoners. Here's what makes this even more ridiculous. We've built the most comfortable prisons in human history. Your living room has better climate control than most research facilities. You can order food from dozens of restaurants without moving from your couch. And your entertainment system offers more content than libraries that existed for centuries. We have literally engineered comfort to the point where leaving our homes feels like an inconvenience rather than a necessity. But here's the thing nobody wants to talk about. What happens when you take a species that evolved under open skies and lock it away from the sun? We're about to find out, and the early results are terrifying. Our homes and offices have become vitamin D deserts. According to StatPearl's research, cutaneous vitamin D synthesis declines significantly with age and darker skin pigmentation, and prolonged indoor living consistently reduces 25-hydroxyvitamin D levels below the critical 30 ng/ml threshold. We've created environments so devoid of natural light that our bodies are shutting down essential biological processes. This isn't just about getting a little pale. We're looking at a deficiency pandemic that makes historical nutritional crises look like minor inconveniences. The Irish potato famine affected about 1 million people. The current vitamin D crisis affects over 1 billion. That's 1 in every 6 humans on the planet walking around with a deficiency that's literally affecting their brain function. The timing couldn't be worse either. Depression rates have increased by 25% since 2020. Anxiety disorders are affecting 40 million adults in the United States alone. Cognitive decline is showing up in younger and younger populations. And here's the connection nobody wants to make. These numbers directly correlate with how much time we spend indoors. The more comfortable we make our indoor environments, the sicker our brains become. Let me paint you a picture of what your typical day looks like. You wake up in a climate-controlled bedroom, probably check your phone before your feet hit the floor. You eat breakfast under LED lights, drive to work in a car with tinted windows, then spend 8 hours in an office building that was designed to keep natural light out. You drive home, again in your tinted window car, and spend your evening binge-watching Netflix or scrolling through social media until you fall asleep. Rinse and repeat for decades. During this entire day, your brain is literally starving. Not for calories, not for information, not for entertainment. It's starving for the specific wavelengths of light that trigger vitamin D production and dozens of other biological processes we're just beginning to understand. Your Netflix binges aren't just entertainment. They're actively rewiring your neural pathways for shorter attention spans, poorer memory consolidation, and reduced cognitive flexibility. Social media makes this even worse. The average person checks their phone 96 times per day. Each time you do this, you're reinforcing neural pathways that prioritize instant gratification over long-term thinking. You're training your brain to expect constant stimulation while simultaneously depriving it of the natural light it needs to function properly. It's like trying to run a car on sugar water instead of gasoline. This creates a perfect storm for what Dr. Roger Sehult describes in his 8-pillar framework for health. Sunlight represents one of these fundamental pillars, but we've systematically removed it from our daily lives. Even in cloudier regions, there are actionable steps people can take to address this deficiency. But first, we need to understand why sunlight exposure is so critical for brain health. Here's what makes sunlight exposure so different from just taking supplements. Your brain has vitamin D receptors scattered throughout every region. These aren't just for bone health. They're controlling neurotransmitter production, regulating inflammation, and managing the cleanup processes that prevent toxic protein buildup. When these receptors don't get adequate vitamin D, your brain starts operating in crisis mode. But taking vitamin D pills isn't the same as getting sunlight. Not even close. When UV rays hit your skin, they trigger a cascade of biological processes. Vitamin D production is just one small part of this cascade. You also get nitric oxide production, which improves blood flow to the brain. You get endorphin release, which improves mood naturally. You get circadian rhythm regulation, which improves sleep quality and memory consolidation. Pills can't replicate any of this. They're like trying to replace a symphony orchestra with a kazoo. Sure, you might get some sound, but you're missing 95% of what makes the experience beneficial. This is why people can take vitamin D supplements for years and still feel terrible. They're treating a sunlight deficiency with a synthetic substitute that barely scratches the surface of what their body actually needs. The indoor lifestyle also creates a vicious cycle that's hard to break. Vitamin D deficiency makes you feel tired and depressed. When you feel tired and depressed, you're more likely to stay indoors and seek comfort through screens and artificial entertainment. This makes the deficiency worse, which makes you feel worse, which keeps you indoors longer. It's a biological trap that millions of people fall into without realizing what's happening. Children are getting caught in this trap earlier than ever before. Kids who used to spend hours playing outside now spend that same time on tablets and gaming systems. Their brains are developing under artificial light, with artificial stimulation, in artificial environments. We're literally raising a generation of humans whose neural development is happening in vitamin D desert conditions. The most disturbing part is how normal this has become. Parents worry more about their kids getting too much sun than too little. Office buildings are designed to eliminate natural light rather than maximize it. We've made our natural light source into a villain while simultaneously creating the conditions for widespread cognitive decline. What we're witnessing is the first generation in human history to voluntarily deprive itself of adequate sunlight on a massive scale. Our ancestors understood that light and health were connected, even if they didn't understand the specific mechanisms. They built their lives around natural light cycles because they had to. We've built our lives around artificial light cycles because we can. The result is a form of modern malnutrition that's affecting our minds more than our bodies. You can be well-fed, well-housed, and well-entertained while your brain slowly starves for the one thing it needs most. But what exactly happens inside your brain when it doesn't get enough sunlight? The answer is more disturbing than most people realize. Your brain on vitamin D starvation. Scientists discovered vitamin D receptors throughout your brain, as documented in University of Texas research on how infrared light regulates melatonin production. These receptors aren't just in your bones like we thought for decades. They're sitting in your hippocampus, your prefrontal cortex, your limbic system. Every major brain region has them. That means vitamin D isn't just preventing rickets. It's directly controlling how your brain functions every single day. The BMC Medicine Dementia cohort studies reveal something that should concern anyone who spends their days indoors. Researchers found J-shaped relationships between light exposure and dementia risk, with specific change points that matter for brain health. People getting less than 1.5 hours of average daily light exposure showed significantly higher cognitive decline. The optimal amounts were around 2 hours in summer and 1 hour in winter. These aren't abstract recommendations. This is measurable brain protection happening when you get adequate light exposure. The neuroimaging studies make this connection even clearer. When researchers scan the brains of vitamin D deficient people, they see patterns that look identical to early-stage dementia. The same protein deposits, the same neural pathway disruptions, the same structural changes that predict cognitive decline. Basically, vitamin D deficiency creates a brain that looks like it's already developing Alzheimer's disease, even in people who are decades away from typical dementia age. This leads to what researchers are calling cognitive winter. Think about what happens to plants when they don't get enough sunlight. They wither, they lose their color, their leaves fall off. Your brain does something similar when it doesn't get enough sunlight-derived nutrients year-round. Your cognitive functions start shutting down. Your memory formation slows. Your ability to focus deteriorates. Your problem-solving skills decline. You're essentially putting your brain into hibernation mode while expecting it to perform at peak capacity. The vitamin D deficiency directly accelerates the formation of amyloid plaques. These are the protein clumps that define Alzheimer's disease. When your vitamin D levels drop, your brain starts producing more of these toxic deposits and becomes less efficient at clearing them out. It's like your brain's garbage disposal system breaks down while the trash keeps piling up. The amyloids accumulate faster, spread wider, and cause more damage than they would if your vitamin D levels were adequate. Your brain does most of its cleaning work while you sleep. During deep sleep phases, cerebrospinal fluid flows through your brain tissue and flushes out metabolic waste products and toxic proteins. Vitamin D deficiency disrupts this entire process. The cleanup crews can't do their job properly. Toxic substances that should get cleared out during the night stick around and cause problems the next day. This is why vitamin D deficient people wake up with mental fog and memory problems even after what feels like adequate sleep. Vitamin D directly controls the production of neurotransmitters like serotonin and dopamine. When your levels drop, your brain can't manufacture enough of these mood-regulating chemicals. This explains why people feel more depressed and anxious during winter months when sunlight exposure decreases. It's not just psychological, it's biochemical. Your brain literally runs out of the raw materials it needs to maintain stable mood and motivation levels. The seasonal depression that affects millions of people is actually acute vitamin D deficiency, manifesting as a psychiatric condition. The mechanisms by which sunlight protects cognitive function go far beyond simple vitamin D production. When infrared light from the sun penetrates your skin, it upregulates mitochondrial melatonin production directly in your brain cells. This process can't happen under artificial lighting. Your neurons need this specific wavelength to maintain their energy production systems and protect against oxidative damage. When UV rays hit your skin, they also trigger the release of nitric oxide, which improves blood flow to brain tissue. Better blood flow means more oxygen and nutrients reaching your neurons. Morning sunlight exposure specifically optimizes the timing of these processes. Your brain needs light signals at precise times to coordinate its daily maintenance cycles. When you avoid sunlight or spend your mornings under artificial lights, you're throwing off these biological clocks. Your memory consolidation happens at the wrong times. Your brain cleanup processes get delayed or disrupted. Your neurotransmitter production cycles become irregular. All of these timing disruptions compound the direct effects of vitamin D deficiency. Different wavelengths of sunlight trigger different beneficial processes in your body and brain. The full spectrum of natural light contains wavelengths that artificial lighting can't replicate. Red and near-infrared light penetrate deeper into tissue and stimulate cellular energy production. Blue light in the morning helps reset your circadian clock. UV light triggers vitamin D synthesis and nitric oxide release. When you replace natural sunlight with LED bulbs and fluorescent fixtures, you're depriving your brain of the complete range of light wavelengths it evolved to use. The research shows that people who maintain adequate vitamin D levels through sun exposure have significantly better cognitive test scores than those with deficiency. They perform better on memory tasks, attention tests, and problem-solving assessments. Their brain scans show more robust neural connectivity and less age-related tissue loss. These cognitive advantages persist even when controlling for other lifestyle factors like exercise, diet, and education level. Understanding all these mechanisms makes one thing crystal clear. Vitamin D isn't just a bone vitamin that happens to affect your brain as a side effect. It's primary brain fuel. Your neurons need it to survive, function, and maintain themselves. When you don't get adequate sunlight, your brain starts operating in starvation mode. And the long-term consequences of this starvation are more devastating than most people realize. The dementia time bomb nobody talks about. The WHO projections should make every health expert lose sleep at night. Dementia cases are projected to triple by 2050, reaching 152 million people worldwide, according to the HNRC Aging Mayor Center consensus. That's not a gradual increase we're talking about. That's an explosion of cognitive decline happening in real time as entire populations age while living indoors. The research shows vitamin D deficiency is a major contributing factor to this crisis, but almost nobody is connecting these dots. New longitudinal studies followed people for decades to see what actually predicts dementia. These weren't short-term studies that might miss important patterns. Researchers tracked the same individuals for 20, 30, even 40 years. The StatPearl's meta-analysis reveals that 15.7% of the global population has vitamin D levels below 30 ng/ml, and large cohort studies consistently link these low levels to accelerated cognitive decline. That's not a small statistical difference. That's a massive predictive factor that could help millions of people avoid dementia. What makes this even more disturbing is the timing. We're creating the perfect storm for cognitive decline right now. Our indoor culture has produced the largest vitamin D deficient population in human history at the exact moment when global life expectancy is increasing. More people are living longer while simultaneously depriving their brains of the nutrients needed to maintain cognitive function. It's like we've figured out how to keep the body alive while letting the mind deteriorate. This raises an uncomfortable question about what we consider normal aging. Maybe the cognitive decline we accept as inevitable isn't actually inevitable. Maybe what we call normal aging is just chronic vitamin D deficiency disguised as the natural consequence of getting older. When you look at populations that maintain adequate sun exposure throughout their lives, they don't show the same patterns of cognitive decline that we see in indoor populations. The geographic data supports this theory. Countries with higher sun exposure have significantly lower rates of dementia, even when researchers control for genetics and lifestyle factors. Mediterranean countries, parts of Africa, and regions near the equator consistently show better cognitive outcomes in their aging populations. This isn't because these populations have better genes or superior medical care. Many of these regions have limited healthcare resources compared to wealthy indoor nations. The difference appears to be sunlight exposure. The possibility that terrifies researchers is what's going to happen to the generation that grew up on screen time and indoor activities. Children who spent their developmental years playing video games instead of playing outside. Teenagers who socialized through social media instead of meeting friends at parks. Young adults who built careers sitting in windowless offices under fluorescent lights. Their brains developed under conditions that no previous generation of humans ever experienced. We're essentially running a massive experiment on human cognitive development, and the early results suggest we're creating unprecedented levels of future dementia risk. A 2025 study found that individuals in the highest tertile of vitamin D intake had significantly reduced odds of low performance on memory and executive function tests. But here's the critical point. The protection came from dietary vitamin D intake, not supplementation. The people with the best cognitive outcomes were getting their vitamin D from food sources that indicated sun exposure and outdoor activity. This brings up the limitation of vitamin D supplementation. Pills can raise your blood levels of vitamin D, but they can't replicate the full spectrum of benefits that come from sunlight exposure. A 2022 study found that the lowest risk of dementia was associated with an average of 1.5 hours of sunlight exposure per day. Not 1.5 hours of taking vitamin D pills. Actual sunlight exposure. The timing of vitamin D deficiency matters more than most people realize. Childhood and middle-age deficiency have the most devastating long-term effects on cognitive function. Your brain undergoes critical development phases during these periods. When vitamin D levels are inadequate during these windows, the damage compounds over decades. By the time cognitive symptoms appear in older age, the underlying deficiency has been causing brain damage for 30 or 40 years. Children who grow up with chronic vitamin D deficiency develop smaller hippocampi and reduced neural connectivity. These structural changes don't reverse when vitamin D levels are corrected later in life. The brain architecture that forms during childhood and adolescence under deficient conditions creates a foundation for cognitive problems that manifest decades later. We're essentially programming future dementia into developing brains through indoor lifestyle choices. Some populations seem naturally protected from dementia despite aging, and their lifestyle patterns provide important clues. Mediterranean populations maintain outdoor activity levels throughout their lives. Many traditional societies never adopted indoor work environments. These groups show remarkably low rates of dementia even when they live to advanced ages. Their protection doesn't come from superior genetics or medical interventions. It comes from maintaining the relationship with sunlight that humans evolved to depend on. The research on optimal sunlight exposure reveals specific patterns that maximize cognitive protection. The study showing 1.5 hours daily as the sweet spot also found that both low and high exposure times increased dementia risk. This suggests there's a precise range of sun exposure that provides maximum brain protection without causing other health problems. The seasonal patterns matter too. 2 hours per day in summer and 1 hour per day in winter provided optimal protection, matching the natural variation in sunlight availability. The UK Biobank research suggests that even brief morning exposure to 10,000 lux natural light for 15-20 minutes can provide significant cognitive benefits. This isn't about spending hours in the sun. It's about consistent, moderate exposure that aligns with how human brains evolve to function. What makes this information so frustrating is how simple the prevention strategy could be. We're looking at a tripling of dementia cases over the next 25 years, but the primary prevention might be as straightforward as spending time outside every day. No expensive medications, no complex medical procedures, just stepping outside and letting sunlight hit your skin for the amount of time humans have been doing for millions of years. The tragedy is that we're choosing to stay indoors instead. We've created environments that feel comfortable and convenient while secretly programming our brains for cognitive decline. The question becomes, what exactly are these indoor environments doing to our brains on a daily basis? Why your couch is a cognitive killer. Your living room's sectional sofa wasn't designed by accident. Furniture companies spend millions of dollars researching how to make couches so comfortable that you never want to leave them. They study the exact angles that make your body relax completely. They engineer cushions that conform to your shape and keep you settled in one position for hours. They create entertainment centers that put everything you need within arm's reach. The result is furniture that actively works against your brain health by keeping you sedentary and indoor-bound. Modern homes combine artificial lighting, climate control, and entertainment systems into environments that create the perfect storm for cognitive decline. Your LED lights emit wavelengths that tell your brain it's perpetually midday, disrupting natural circadian rhythms. Your air conditioning maintains temperatures that prevent beneficial stress responses your brain needs to stay sharp. Your sound system and streaming services provide constant stimulation that trains your brain to expect artificial entertainment rather than natural environmental input. These systems work together to create spaces that feel incredibly comfortable while slowly destroying your cognitive function. Research shows that people who spend more time on couches have measurably smaller hippocampi. The hippocampus is your brain's memory center, responsible for forming new memories and connecting them to existing knowledge. When this brain region shrinks, your ability to learn new information and retrieve stored memories deteriorates. The sedentary lifestyle that couches promote doesn't just affect your physical fitness. It directly impacts the size and function of brain structures critical for cognitive performance. We've created what researchers call domestic hibernation. Our homes have become caves we never leave, triggering biological shutdown processes that evolved to help humans survive harsh winters when food was scarce and activity needed to be minimized. But we're activating these hibernation responses year-round in environments where food is abundant and physical activity is optional. Your brain interprets prolonged indoor living as a signal to conserve energy and reduce metabolic activity. Neural connections that aren't regularly stimulated start getting pruned away. Cognitive processes that aren't frequently used begin shutting down. The blue light from screens combined with lack of natural light creates a toxic cocktail for brain function. Blue light exposure after sunset suppresses melatonin production, which disrupts sleep quality and prevents proper memory consolidation. During the day, blue light from screens provides the wrong type of stimulation at the wrong intensity. Your brain expects the full spectrum of natural sunlight with varying intensities throughout the day. Instead, it gets narrow-spectrum LED light at constant brightness levels. This artificial light environment confuses your brain's internal clock and disrupts the timing of essential cognitive processes. The U.S. Pointer results demonstrate that lifestyle interventions focusing on outdoor sitting time and natural light exposure significantly improve cognitive outcomes compared to indoor sedentary behavior. This research confirms that the comfort features of modern furniture actively work against the brain's need for environmental variation and natural stimulation. Prolonged sitting in artificial environments creates inflammatory effects that reach the brain, but walking outdoors lowers inflammatory markers and improves memory performance, as demonstrated in lockdown and air pollution studies. The lack of natural light cycles disrupts circadian rhythms, leading to poor sleep quality that accelerates cognitive decline. Your brain relies on light signals to coordinate the timing of memory consolidation, protein synthesis, and cellular repair processes. When you spend your days under artificial lights and your evenings in front of screens, these timing signals get scrambled. Your brain doesn't know when to consolidate memories from the day. Your neurons don't know when to activate repair mechanisms. Your glial cells don't know when to clear out metabolic waste. All of these processes happen at the wrong times or don't happen at all. Sleep quality deterioration creates a cascade of cognitive problems that compound over time. During deep sleep phases, your brain flushes out amyloid proteins and other toxic substances that accumulate during waking hours. When artificial light disrupts these sleep cycles, the cleanup process becomes inefficient. Toxic proteins start building up in brain tissue, particularly in regions responsible for memory and executive function. Over months and years, this protein accumulation leads to the same type of brain damage seen in neurodegenerative diseases. The entertainment systems that make couches so appealing also rewire your brain for instant gratification and shortened attention spans. Streaming platforms use algorithms designed to keep you watching by providing constant stimulation and frequent content changes. Your brain adapts to expect this level of artificial excitement, making natural environments seem boring by comparison. The neuroplasticity that allows your brain to adapt to new experiences works against you when the experiences are designed to be addictive rather than beneficial. Indoor air quality compounds the cognitive problems created by sedentary living. Modern homes are sealed environments with limited air circulation. The air you breathe while sitting on your couch contains higher concentrations of carbon dioxide, volatile organic compounds from furniture and cleaning products, and fewer negative ions that help improve cognitive function. Poor air quality reduces oxygen availability to brain tissue and introduces toxins that impair neural function. The social isolation that often accompanies couch-based entertainment further damages cognitive health. Human brains evolve to function in social groups with complex interpersonal interactions. When you replace social interaction with screen-based entertainment, you're not exercising the neural networks responsible for emotional intelligence, empathy, and social problem-solving. These cognitive abilities deteriorate without regular use, leading to reduced mental flexibility and impaired decision-making skills. Your couch creates a perfect environment for cognitive decline by combining multiple brain-damaging factors in one comfortable package. Sedentary positioning reduces blood flow. Artificial lighting disrupts circadian rhythms. Climate control eliminates beneficial stress responses. Entertainment systems train your brain for instant gratification. Social isolation reduces cognitive stimulation. Poor air quality impairs neural function. Each factor alone can damage cognitive performance, but their combination creates an environment that actively accelerates brain aging. The irony is that the spaces designed to provide maximum comfort and convenience are the ones causing the most long-term damage to your cognitive health. Your brain interprets the comfort and safety of indoor environments as signals to reduce alertness and conserve energy. The very features that make modern homes appealing to conscious minds are triggering subconscious biological responses that shut down cognitive function. We've created living spaces that feel like luxury resorts while functioning like cognitive prisons. Understanding how indoor environments damage brain health reveals why sunlight exposure becomes so critical for cognitive protection. Natural light signals alert your brain to maintain active metabolic processes. Temperature variations keep stress response systems functioning properly. Physical movement maintains blood flow to neural tissue. Outdoor environments provide the sensory stimulation and biological signals that your brain needs to stay sharp and resilient throughout your lifespan. But there's something else we need to address about our relationship with sunlight that might surprise you. The sunlight conspiracy nobody wants you to know. The shift from heliotherapy to sun avoidance in medical practice represents one of the most dramatic reversals in healthcare history. In the early 20th century, doctors actually prescribed sunlight as medicine. They called it heliotherapy, and they used it to treat tuberculosis, depression, and dozens of other conditions. Niels Finsen won the Nobel Prize in 1903 for his phototherapy research demonstrating how light could cure diseases. Patients would spend hours in specially designed sunrooms, and many of them recovered from diseases that killed millions of other people. Then something changed in the 1980s. Dermatologists started campaigns that painted UV radiation as pure evil, and we went from prescribing sunlight to treating it like poison. Here's the statistic that should make everyone question this approach. Skin cancer kills about 7,000 people per year in the United States. Diseases linked to vitamin D deficiency kill over 200,000 people annually. Heart disease, diabetes, multiple sclerosis, depression, dementia. The list goes on and on. We're talking about a 30-to-1 ratio of deaths. For every person who dies from skin cancer, 30 people die from diseases that adequate sunlight could have prevented. Yet our entire medical system focuses on the smaller threat while ignoring the massive one. The sunscreen industry is worth $10.1 billion in 2024, and their profits depend entirely on keeping people afraid of the sun. According to Rolling Stone's investigation into pharmaceutical lobbying, sunscreen manufacturers fund research that specifically links sun exposure only to skin cancer, while systematically ignoring studies showing protective effects against other diseases. These companies make money when people believe that any sun exposure is dangerous. This creates a massive conflict of interest that nobody wants to talk about. The same industry that profits from sun avoidance is funding the research that tells us to avoid the sun. Moderate sun exposure actually reduces overall cancer risk, not just skin cancer. Multiple studies show that people with regular sun exposure have lower rates of colon cancer, breast cancer, prostate cancer, and lymphomas. The protective effects of vitamin D and other sun-derived compounds outweigh the increased risk of skin cancer for most people. But you'll never hear this from dermatologists who built their careers on sun avoidance messaging. They've invested too much professional credibility in the idea that all sun exposure is harmful. The medical establishment's focus on skin cancer has completely ignored the massive benefits of sunlight for brain health. A 2022 study in BMC Med found that time spent in outdoor light is associated with a reduced risk of dementia. This isn't a small effect we're talking about. The people with the most outdoor light exposure had significantly lower rates of cognitive decline compared to those who stayed indoors. But when was the last time a dermatologist mentioned this research? When did a skin cancer prevention campaign talk about dementia prevention through sunlight? Different skin types need different amounts of sun exposure, and blanket sun avoidance advice is dangerous for many people. Someone with very fair skin might need only 10 minutes of midday sun to produce adequate vitamin D. Someone with darker skin might need an hour or more to get the same benefit. The current medical advice treats everyone the same. telling all people to avoid sun exposure regardless of their skin type, geographic location, or baseline vitamin D levels. This one-size-fits-all approach creates deficiency in millions of people who could safely get adequate sun exposure. WHO data reveals that vitamin D deficiency increases respiratory infection risk by 12% to 21%, with NHANES and Frontiers research confirming this pattern across populations. Yet respiratory infections kill far more people annually than skin cancers, particularly in vulnerable populations like the elderly and immunocompromised. The focus on preventing skin cancer while ignoring respiratory disease prevention through adequate vitamin D represents a massive misallocation of public health resources. People with higher sun exposure live longer, healthier lives despite slightly higher skin cancer rates. The research consistently shows this pattern across different populations and geographic regions. Outdoor workers have lower rates of multiple sclerosis and colorectal cancer compared to indoor populations. People living in sunny climates have better cognitive function and lower rates of depression. Mediterranean populations with high sun exposure have some of the longest lifespans in the world. The slight increase in skin cancer risk gets overwhelmed by the massive decreases in other disease risks. Vitamin D supplementation became a convenient substitute that doesn't provide the full spectrum of benefits from natural sunlight. The supplement industry loves this approach because it turns a free natural resource into a profitable product. Take these pills instead of going outside. It's easier, more convenient, and generates revenue for pharmaceutical companies. But pills can't replicate the nitric oxide production that happens when sunlight hits your skin. They can't trigger the endorphin release that improves mood naturally. They can't regulate your circadian rhythms or stimulate the heat shock proteins that protect your brain cells. A 2023 study in the Journal of Investigative Dermatology found that low-level UV exposure activates cutaneous regulatory T cells, which suppress autoimmune responses without increasing melanoma risk. This is exactly the type of research that gets buried under skin cancer fear campaigns. Your skin has sophisticated mechanisms for handling moderate UV exposure safely. These protective systems evolved over millions of years of human sun exposure. They don't just prevent damage. They actually use sunlight to improve immune function and reduce disease risk. The timing of the sun phobia campaigns coincided perfectly with the rise of indoor entertainment and office work. In the 1980s, personal computers became common in workplaces. Cable television expanded entertainment options. Video games started keeping kids indoors for hours. Air conditioning made indoor spaces comfortable year-round. The medical advice to avoid sun exposure aligned perfectly with lifestyle changes that were already pushing people indoors. Nobody questioned whether this combination might create health problems down the road. Chronic diseases cost the U.S. healthcare system $3.5 trillion annually, and many of these diseases are linked to vitamin D deficiency. Heart disease, diabetes, depression, dementia, autoimmune disorders. The list includes most of the major killers in developed countries. If adequate sunlight could prevent even a fraction of these cases, the economic benefits would dwarf the costs of treating additional skin cancers. But the medical system profits more from treating chronic diseases than from preventing them through lifestyle changes. The sun isn't the enemy. Our disconnection from it is killing us slowly, and we've been convinced it's for our own good. We've created a generation of people who are literally afraid of the star that made life possible on this planet. The same energy source that powers photosynthesis and drives weather patterns has been rebranded as a threat to human health. This represents one of the most successful marketing campaigns in medical history, and the results are becoming impossible to ignore. The 1.2 billion person vitamin D crisis. The scale of this health crisis becomes clear when you examine the numbers. According to StatPearl's research, global subclinical vitamin D deficiency affects up to 1 billion people, with insufficiency reaching 50% of the population in many regions. That's nearly 1 in 6 humans walking around with blood levels so low their bodies can't function properly. We're looking at the largest nutritional deficiency in human history, and it's happening right now while most people spend their days indoors. The Frontiers in Nutrition meta-analysis reveals that deficiency rates reached 17.6% between 2000 and 2010, then decreased slightly to 14.1% from 2011-2022. But this modest improvement still represents hundreds of millions of people with dangerously low vitamin D levels. The cardiovascular disease deaths linked to vitamin D deficiency, as documented in the archives of internal medicine meta-analysis, create mortality numbers that rival major historical health crises. The difference is that vitamin D deficiency kills slowly and quietly, not dramatically like infectious diseases. What makes this crisis particularly disturbing is how it correlates with modern lifestyle patterns. The highest rates of vitamin D deficiency don't occur randomly across populations. They cluster in specific demographics that share common indoor lifestyle characteristics. Countries with the highest rates of internet usage, smartphone ownership, and indoor employment consistently show the most severe deficiency patterns. Nations where people spend the most time in air-conditioned buildings, driving cars with tinted windows, and working under artificial lights demonstrate the strongest correlation between technological advancement and vitamin D deficiency. Certain demographics are getting hit hardest by this crisis. Office workers who spend 8 hours daily under fluorescent lights show deficiency rates above 80%. People in tech industries and gamers have some of the lowest vitamin D levels ever recorded in healthy populations. Healthcare workers, ironically, have among the highest deficiency rates of any profession. Doctors, nurses, and hospital staff spend their careers in windowless buildings under artificial lighting, slowly destroying their own vitamin D status while treating patients for diseases their lifestyle choices help create. The COVID-19 pandemic accelerated this crisis beyond anything researchers predicted. Lockdowns pushed millions of people indoors for months at a time. Remote work eliminated commutes that provided brief sun exposure. Gym closures ended outdoor exercise routines. Social distancing reduced time spent in parks and outdoor spaces. The research shows deficiency rates jumped by 15–20% during the pandemic years, creating the steepest increase in vitamin D deficiency ever recorded. Remote work culture has made this problem permanent for millions of people. Before the pandemic, office workers at least walked from parking lots to buildings or caught sunlight during lunch breaks. Now people wake up in their bedrooms, walk to their home offices, and spend entire days without stepping outside. They order groceries online, stream entertainment, and socialize through screens. Some remote workers report going weeks without meaningful sun exposure, creating deficiency levels that would have been impossible before 2020. Modern architecture compounds the problem even for people who work near windows. Office buildings use tinted glass that blocks the UV radiation needed for vitamin D production. These windows might let invisible light, but they filter out the specific wavelengths that trigger vitamin D synthesis in your skin. You can sit next to a window for 8 hours and still develop deficiency because the glass is designed to protect you from the very radiation your body needs. The deficiency crisis disproportionately affects older adults who need more sun exposure but get less due to mobility and lifestyle changes. As people age, their skin becomes less efficient at producing vitamin D from sunlight. A 70-year-old needs 4 times more sun exposure than a 20-year-old to produce the same amount of vitamin D, but older adults spend more time indoors, have less mobility to seek sun exposure, and often live in care facilities with limited outdoor access. The research reveals that the Eastern Mediterranean region has the highest prevalence of vitamin D deficiency at 35.2% of the population. This seems counterintuitive for a sunny region, until you understand the cultural and lifestyle factors involved. Many people in these regions wear clothing that covers most of their skin. They spend daylight hours indoors and avoid sun exposure due to cultural preferences. Modern urbanization has moved populations into high-rise buildings and air-conditioned environments that eliminate natural sun exposure. Lower middle-income countries show deficiency rates of 26.7%, while higher-income nations often have comparable or worse rates despite better healthcare access. The pattern shows that economic development often correlates with lifestyle changes that reduce sun exposure. Wealth allows people to avoid sunlight through climate control, indoor entertainment, and car transportation. Meanwhile, populations with less access to indoor technology often maintain better vitamin D levels through outdoor work and activities. Geographic latitude plays a crucial role, but lifestyle factors often override geographic advantages. People living in higher latitudes do have increased deficiency risk due to reduced sunlight availability. But populations living near the equator with abundant sunlight still develop deficiency when they adopt indoor lifestyles. Some northern populations maintain adequate vitamin D levels through outdoor activities and intelligent sun exposure timing. The health consequences of this massive deficiency are already creating unprecedented disease patterns across populations worldwide. Autoimmune diseases are increasing at rates that correlate directly with vitamin D deficiency prevalence. Multiple sclerosis, type 1 diabetes, and inflammatory bowel diseases show their highest rates in the most vitamin D deficient populations. Depression and anxiety rates track closely with indoor lifestyle patterns. Children born into this deficiency crisis are developing with fundamentally altered immune systems and bone development patterns. Their brains are forming neural pathways under conditions that no previous generation of humans ever experienced. We're essentially conducting a massive experiment on human development using an entire generation as test subjects. The obvious solution seems straightforward. If over 1 billion people are vitamin D deficient, just give them vitamin D supplements. The supplement industry has certainly embraced this logic, creating a massive market built on the promise of fixing deficiency with pills. But the results tell a different story entirely. Why vitamin D pills are like bringing a knife to a gunfight. Americans spend over $1.2 billion annually on vitamin D supplements, yet deficiency rates keep climbing year after year. This creates an obvious question that nobody in the supplement industry wants to answer. If these pills work so well, why are more people becoming deficient despite taking them? The uncomfortable truth is that supplementation raises 25-hydroxyvitamin D levels modestly, while sunlight triggers multiple pathways that pills simply cannot access. Taking vitamin D pills gives you one isolated compound while ignoring the dozens of other processes that sunlight triggers in your body. When UV rays hit your skin, they start a cascade of biological reactions that scientists are just beginning to understand. Vitamin D production is actually one small part of this complex system. Sunlight's UV triggers nitric oxide release that improves blood flow, a benefit pills can't replicate, as documented in BMC influenza findings. You also get endorphin production, which naturally elevates mood without side effects. You get heat shock protein activation, which protects your cells from damage and helps repair existing problems. Research consistently shows that people who get vitamin D from sunlight have better health outcomes than those who rely on supplements. Dr. Roger Sehult points out that those with low vitamin D levels are often those who are not getting enough sun exposure. The key word here is exposure, not supplementation. Your body evolved to use sunlight as a trigger for multiple beneficial processes, not just vitamin D creation. When you bypass this natural system with pills, you miss most of the health benefits that made vitamin D important in the first place. Sunlight triggers beneficial processes in your body that have nothing to do with vitamin D production. The infrared light from the sun can penetrate up to about 8 cm and fundamentally interacts with the mitochondria, according to research Dr. Sehult discusses. According to the melatonin research paper, infrared light upregulates mitochondrial melatonin production, creating cellular protection that no supplement can provide. These longer wavelengths stimulate cellular energy production in ways that no supplement can replicate. Your mitochondria, the powerhouses of your cells, respond directly to specific wavelengths of sunlight by producing more ATP and reducing oxidative stress. This happens regardless of whether you're making vitamin D or not. The bioavailability and effectiveness of natural vitamin D far exceeds synthetic supplements for reasons that pharmaceutical companies don't advertise. When your skin produces vitamin D from sunlight, it creates the exact molecular structure your body expects to use. The vitamin D in pills goes through industrial manufacturing processes that create slightly different molecular configurations. Your digestive system has to break down these synthetic versions and convert them into usable forms, losing efficiency at every step. Many people take vitamin D supplements for months without seeing improvement in their blood levels because their bodies can't effectively process the artificial versions. Supplement timing, dosage, and individual absorption rates make pill-based approaches unreliable for most people. Some individuals need 1,000 IU daily to maintain adequate levels. Others need 5,000 IU or more to see any improvement. Your age, weight, digestive health, and genetic factors all affect how well you absorb vitamin D from pills. The research suggests initial supplementation for 8 weeks with vitamin D3, either 6,000 IU daily or 50,000 IU weekly. But these doses represent educated guesses rather than personalized medicine. Sunlight exposure automatically adjusts to your individual needs because your skin stops producing vitamin D when you have adequate levels. Individual genetic variations affect vitamin D production rates, with British Medical Journal research showing that some people require 15-20 minutes of summer sun in England, while others need significantly more. These same genetic differences also affect how well people absorb supplements, making standardized dosing even less reliable. The pharmaceutical approach to vitamin D deficiency completely ignores the root cause, which is lack of sun exposure. Instead of addressing why people aren't getting sunlight, the medical system prescribes pills to treat the symptoms of sun avoidance. This is like treating dehydration with IV fluids while ignoring the fact that the patient isn't drinking water. Dr. Sehult notes that the biggest barrier to getting patients outside is staff taking those patients outside. The healthcare system has structured itself around indoor treatments rather than natural solutions that require lifestyle changes. Your body produces vitamin D in response to UVB radiation, but it also responds to UVA, infrared, and visible light wavelengths that trigger completely separate biological processes. UVA radiation penetrates deeper into your skin and affects immune system function. Infrared light stimulates mitochondrial activity and cellular repair mechanisms. Visible light regulates circadian rhythms and neurotransmitter production. When you take vitamin D pills, you get none of these additional benefits. You're essentially taking one ingredient from a complex recipe and expecting it to provide the same results as the complete formula. The research reveals unknown benefits of sunlight that we're missing when we rely solely on supplements. Scientists have identified that sunlight exposure stimulates and upregulates melatonin, which prevents a lot of diseases like dementia, cardiovascular disease, diabetes. This melatonin production happens through pathways that vitamin D pills cannot activate. Your skin contains cells that produce melatonin when exposed to specific wavelengths of light. This local melatonin production provides antioxidant protection and cellular repair benefits that systemic melatonin supplements don't offer. Supplement manufacturers have convinced millions of people that vitamin D deficiency is a pill deficiency rather than a sunlight deficiency. This marketing approach generates billions in revenue while keeping people indoors and dependent on pharmaceutical products. The vitamin D supplement industry benefits when people believe that pills are equivalent to natural sunlight exposure. They fund research that focuses on vitamin D blood levels rather than overall health outcomes from sun exposure versus supplementation. The timing of vitamin D production from sunlight provides natural regulation that pills cannot replicate. Your skin produces vitamin D most efficiently during midday hours when UVB radiation is strongest. This timing coincides with other circadian processes that optimize vitamin D utilization. Taking pills at random times throughout the day disrupts these natural rhythms and reduces the effectiveness of the vitamin D you're consuming. Treating vitamin D deficiency with pills is like treating loneliness with a photograph of friends. You might technically address the measurable deficiency, but you miss the complex web of benefits that come from the natural source. Your blood levels might improve on paper, but your overall health outcomes remain compromised because you're still avoiding the sunlight exposure that triggers dozens of beneficial processes your body needs to function optimally. This supplement dependency becomes even more problematic when you consider how modern technology actively works against the natural solutions our bodies need. The very devices we use to research vitamin D supplements are keeping us indoors longer, creating a cycle where we treat sun avoidance with pills while the real problem continues getting worse. The screen addiction brain drain. The digital devices we turn to for entertainment are systematically destroying the cognitive abilities we need to function in the real world. The average person now spends over 7 hours daily staring at screens, often in dimly lit indoor environments that actively work against brain health. That's nearly half of your waking hours with your eyes locked onto artificial light sources, while your brain slowly starves for the natural light it needs to function properly. This screen time has increased by 30% since 2019, meaning we're spending more time looking at phones, computers, and televisions than our ancestors spent hunting, gathering, and surviving in natural environments. This screen addiction directly correlates with vitamin D deficiency and accelerated cognitive decline in ways that researchers are just beginning to understand. UK Biobank data shows that prolonged screen time reduces outdoor time by 50% in their sample population, and pandemic cohorts demonstrate 30% higher deficiency rates among heavy screen users. The correlation isn't coincidental. Screen time keeps you indoors, away from sunlight, while simultaneously disrupting the biological processes that help your body utilize whatever vitamin D you do manage to produce. New research reveals that excessive screen use combined with sun avoidance creates a perfect storm for brain deterioration that surpasses the cognitive damage from either factor alone. The combination amplifies the negative effects of both behaviors. Screen addiction reduces your motivation to go outside, while vitamin D deficiency makes you feel tired and depressed, which drives you to seek comfort through more screen-based entertainment. This creates a downward spiral that becomes harder to break as it progresses. Digital dementia represents a new category of cognitive decline, where our devices literally rewire our brains for shorter attention spans and poorer memory function. Your brain adapts to the constant stimulation and rapid content changes that screens provide. Neural pathways that support sustained concentration start getting pruned away because they're not being used. Memory formation becomes less efficient because your brain expects information to be available instantly rather than stored for later recall. The plasticity that allows your brain to adapt to new environments works against you when those environments are designed to be addictive rather than beneficial. Blue light suppresses melatonin and damages retinal mitochondria, while morning sun exposure for 10-15 minutes resets circadian rhythms and eye health. Screen light also suppresses melatonin production, which has cascading effects on cognitive function that extend far beyond sleep quality. Melatonin doesn't just make you sleepy. It acts as a powerful antioxidant that protects brain cells from damage and helps clear out toxic proteins during sleep. When blue light suppresses melatonin production, your brain misses these protective and repair processes. Screen addiction creates a vicious cycle where poor mood from vitamin D deficiency drives more screen time, which worsens the deficiency and mood problems. When you feel depressed or anxious from vitamin D deficiency, screens provide temporary distraction and artificial stimulation that seems to help. But this relief is short-lived and comes at the cost of further reducing your motivation to engage in behaviors that would actually improve your mood, like spending time outdoors. The more depressed you feel, the more you rely on screens for comfort, creating a cycle that becomes increasingly difficult to break. Children and teenagers face particular vulnerability because their brains are still developing during their highest screen exposure years. The neural pathways forming during childhood and adolescence create the foundation for adult cognitive function. When these pathways develop under conditions of excessive artificial stimulation and inadequate natural light, they create brain architectures optimized for screen-based environments rather than real-world problem-solving. Young people who grow up with high screen time show reduced gray matter in areas responsible for executive function, emotional regulation, and impulse control. The developing teenage brain is especially susceptible to the addictive properties of screen-based entertainment. Adolescent brains produce higher levels of dopamine in response to novel stimuli, making teenagers more likely to become dependent on the constant stream of new content that screens provide. Their prefrontal cortex, responsible for decision-making and impulse control, isn't fully developed until age 25, making it harder for them to recognize and resist the harmful effects of excessive screen time. Screen environments also eliminate the natural stress responses that help developing brains build resilience and adaptability. Real-world environments provide unpredictable challenges that require creative problem-solving and physical responses. Screen environments provide predictable, low-stakes stimulation that doesn't exercise the same cognitive abilities. Children who spend most of their time in artificial environments develop brains that are less capable of handling real-world stress and uncertainty. Breaking this destructive cycle requires understanding that screen addiction and vitamin D deficiency reinforce each other through multiple biological and psychological mechanisms. Your brain needs the full spectrum of sunlight wavelengths at appropriate intensities throughout the day to maintain optimal function. No amount of blue light filtering can replace the biological benefits of spending time outdoors. The entertainment industry profits from keeping you indoors and dependent on artificial stimulation. You're literally paying subscription fees for platforms that are designed to damage your cognitive function, while keeping you away from the free natural resource your brain needs most. Our entertainment choices are entertaining our brains to death, creating cognitive decline that we're funding through monthly subscription payments to streaming services that optimize for addiction rather than well-being. This screen-driven lifestyle doesn't just affect how we think and remember. It fundamentally alters our brain chemistry in ways that create what millions of people experience as mood disorders, particularly during certain times of the year when the effects become impossible to ignore. The shocking truth about winter depression. Seasonal depression represents one of the clearest examples of how vitamin D deficiency gets misdiagnosed as a psychiatric condition. Every winter, millions of people develop symptoms that doctors diagnose as seasonal affective disorder or major depressive episodes. They prescribe antidepressants, recommend therapy, and suggest coping strategies for managing seasonal mood changes. But meta-analyses show a 2.58x risk of depression from low sun exposure, according to Lancet Diabetes and Endocrinology Research, while bright light therapy produces dramatic improvements that antidepressants simply cannot match. This creates a massive misdiagnosis epidemic that affects roughly 10 million Americans annually. Patients walk into doctors' offices complaining of fatigue, depression, anxiety, and cognitive fog during winter months. Instead of checking their vitamin D levels or asking about sunlight exposure, physicians immediately prescribe psychiatric medications. These medications treat the symptoms while completely ignoring the underlying cause. Antidepressants show 24-hour symptom reduction, while light therapy shortens hospital stays by 4 days in influenza-like illness studies. Yet the medical system continues prioritizing pharmaceutical approaches over natural interventions. Psychiatric medications cannot fix a nutritional deficiency, yet this approach represents standard treatment in most medical practices. Antidepressants work by artificially manipulating neurotransmitter levels in the brain. They force neurons to maintain higher concentrations of serotonin and other mood-regulating chemicals. But when vitamin D deficiency prevents your brain from producing adequate amounts of these neurotransmitters naturally, You're trying to solve a supply problem with a recycling strategy. The medications might make existing neurotransmitters work more efficiently, but they can't create new ones from nutrients that aren't available. The geographic evidence makes this connection undeniable. Countries with longer winters consistently show higher rates of depression, suicide, and cognitive decline. Iceland, Norway, and Alaska have suicide rates that are 2-3 times higher than countries closer to the equator. Finland has depression rates that peak during the months with the least sunlight and drop dramatically during summer. These aren't cultural differences or genetic variations. They're biological responses to inadequate light exposure, affecting entire populations. Sweden provides a particularly clear example of how sunlight affects mental health on a national scale. During the winter months, when daylight lasts only a few hours, hospital admissions for depression increase by 40%. Suicide attempts spike in February and March when vitamin D levels reach their lowest point. But during the summer months, when Sweden experiences nearly 24 hours of daylight, these same populations show depression rates lower than most sunny countries. The same people in the same environment experience dramatically different mental health outcomes based solely on their sunlight exposure. Research consistently demonstrates that light therapy produces better outcomes than medication for seasonal mood disorders. Patients who receive bright light therapy for 30 minutes each morning show improvement rates of 60-70% within 2 weeks. Compare this to antidepressants, which take 4-6 weeks to show effects and work in only 40-50% of patients. Light therapy addresses the actual cause of the problem by providing the light signals that regulate circadian rhythms and support neurotransmitter production. Medications only mask the symptoms while the underlying deficiency continues. Vitamin D serves as a precursor for serotonin synthesis, and low levels reduce mood-regulating neurotransmitters throughout the brain. According to Mayo Clinic and Nutrition Bulletin research, your brain needs vitamin D to convert tryptophan into serotonin, the neurotransmitter responsible for mood stability and feelings of well-being. When vitamin D levels drop, this conversion process becomes inefficient. Your brain can't produce enough serotonin even when you consume adequate amounts of tryptophan through diet. This creates the classic symptoms of depression, including low mood, reduced motivation, and disrupted sleep patterns. The timing of these biochemical changes matches perfectly with seasonal patterns of depression. Vitamin D levels typically peak in late summer and reach their lowest point in late winter or early spring. This corresponds exactly with when seasonal depression symptoms are most severe. The lag time between reduced sunlight exposure and the development of depression symptoms reflects how long it takes for vitamin D stores to become depleted and for neurotransmitter production to be affected. Dopamine production also depends on adequate vitamin D levels. This neurotransmitter controls motivation, reward processing, and the ability to experience pleasure. When vitamin D deficiency reduces dopamine production, people lose interest in activities they previously enjoyed. They feel unmotivated and struggle to find pleasure in normal experiences. These symptoms are often misinterpreted as psychological problems, rather than recognized as the biochemical consequences of nutritional deficiency. People who maintain adequate vitamin D levels year-round don't experience seasonal mood variations. Studies following individuals with consistent vitamin D levels above 40 ng/ml show stable mood patterns regardless of season. These people don't develop winter depression, don't experience seasonal energy drops, and maintain consistent cognitive performance throughout the year. Their brains continue producing neurotransmitters at optimal levels because they have the nutritional building blocks needed for synthesis. The connection between sunlight and mental health isn't widely recognized in medical practice because the medical system has structured itself around treating diseases rather than preventing them through environmental modifications. Medical schools spend minimal time teaching about nutritional psychiatry or the role of vitamin D in brain function. Most physicians receive extensive training in pharmaceutical interventions, but limited education about lifestyle factors that affect mental health. Insurance reimbursement systems also favor pharmaceutical treatments over lifestyle interventions. Doctors get paid for prescribing medications and conducting therapy sessions. They don't get reimbursed for recommending sunlight exposure or teaching patients about vitamin D optimization. This creates economic pressures that push healthcare providers toward profitable treatments rather than effective ones. Winter depression isn't an inevitable consequence of seasonal changes. It's a preventable result of indoor lifestyle choices that disconnect us from the natural light our brains need to function properly. Understanding this connection opens up possibilities for addressing the root cause rather than just managing symptoms. The question becomes how to practically implement this knowledge in daily life, especially for people who feel trapped by work schedules and indoor obligations. Your action plan for escaping the indoor prison. Reversing vitamin D deficiency and protecting your brain health requires strategic changes to how you interact with sunlight throughout your day. You don't need expensive medical procedures or complex supplement regimens. You don't need to move to a tropical climate or quit your indoor job. The solution involves making small, targeted adjustments that can start improving your cognitive function within weeks and provide long-term protection against dementia and depression. Your daily sunlight exposure plan needs to work around your existing schedule, not replace it entirely. The optimal approach involves getting sunlight exposure at specific times when your skin produces vitamin D most efficiently, while your schedule allows for brief outdoor breaks. Most people can implement this strategy, even with demanding indoor jobs, by focusing on morning exposure, lunch breaks, and evening light. Morning sunlight exposure between 7 a.m. and 10 a.m. provides the most powerful benefits for brain health and circadian rhythm regulation. During these hours, you get proportionally more infrared light and less harsh ultraviolet radiation. This timing works perfectly for most people because you can get exposure while walking to your car, having coffee outside, or taking a brief walk before work starts. The UK Biobank research shows that 3,000 lux for 20 minutes provides optimal light therapy benefits, which translates to just 15-20 minutes of morning sun on your face and arms to trigger vitamin D production while setting your biological clock for optimal cognitive function throughout the day. The research shows that the optimal time for sunlight exposure is in the morning and evening, when the sun is lower in the sky. During these periods, your skin can safely produce vitamin D without the intense UV radiation that occurs at midday. This makes morning and evening exposure ideal for people who are just starting to rebuild their relationship with sunlight after years of indoor living. Creative solutions can dramatically increase your natural light exposure, even in traditional office environments. Walking meetings provide double benefits by combining movement with sunlight exposure. Instead of sitting in conference rooms, suggest outdoor discussions for appropriate topics. Lunch breaks become opportunities for 20-30 minutes of direct sunlight rather than more time under fluorescent lights. Even brief 5-minute walks between meetings add up to significant light exposure over the course of a workday. Office workers can position their desks near windows to maximize whatever natural light penetrates indoor spaces. However, remember that most office windows filter out the UV radiation needed for vitamin D production. The visible light still helps with circadian rhythm regulation and mood improvement, but you'll need actual outdoor time for vitamin D synthesis. Small changes like outdoor lunch breaks can dramatically improve cognitive function within just a few weeks. People who start eating lunch outside report better afternoon focus, improved mood, and more energy for the rest of their workday. The combination of natural light, fresh air, and brief movement breaks interrupts the cognitive fatigue that builds up from continuous indoor exposure. Morning sun exposure specifically optimizes neurotransmitter production for the entire day. When sunlight hits your eyes and skin in the morning, it triggers the production of serotonin and dopamine while suppressing daytime melatonin. This creates natural energy and focus that carries through your work hours without the crash associated with caffeine or artificial stimulants. Different climates and seasons require adapted strategies that account for sunlight availability and weather conditions. People living in northern latitudes during winter months need to maximize their exposure during the limited daylight hours available. This might mean taking lunch breaks outside, even when it's cold, or scheduling morning walks during the brief period when the sun is visible. For those in areas with limited sunlight, Dr. Sehult recommends using SAD lamps about 11 to 16 inches from your face for about 20 minutes, which should provide about 3,000 lux hours. However, he emphasizes that this will not replace the effect that the sun has on your mitochondria. These devices serve as supplements to natural light, not replacements for it. Cloudy climates still provide benefits from outdoor exposure. As Dr. Sehult notes, even on cloudy days, you can still get the light you need, but not as much as on a sunny day. The key is understanding that outdoor light on cloudy days is still many times brighter than indoor lighting. Your brain and body respond to this increased light intensity even when direct sunlight isn't available. Winter strategies focus on maximizing exposure during available daylight hours. This might mean adjusting your schedule to take advantage of midday light when the sun is strongest. Some people find success with brief outdoor exposure during their commute or scheduling outdoor activities on weekends when they have more flexibility. Use 2,400 IU vitamin D3 daily only if testing shows deficiency. Then taper when natural sun exposure improves, following Endocrine Society guidelines. If blood testing reveals severe deficiency, temporary supplementation can help restore levels while you build outdoor exposure habits. This approach positions vitamin D pills as backup support, not primary strategy. Incorporating vitamin D-rich foods like fatty fish alongside sun exposure creates a comprehensive approach that aligns with StatPearl's nutrition guidelines. A balanced diet supports your body's ability to utilize the vitamin D produced through sunlight exposure while providing other nutrients essential for cognitive health. Tracking your vitamin D levels through regular blood tests provides objective feedback on your optimization efforts. Many people see levels improve from deficient ranges below 20 ng/ml to optimal ranges above 40 ng/ml within 3-6 months of consistent sunlight exposure. This measurable improvement motivates continued behavior change and helps you adjust your exposure timing and duration. Cognitive improvements often appear before blood level changes become apparent. People typically notice better mood, improved sleep quality, and sharper mental focus within 2-3 weeks of starting regular sunlight exposure. These subjective improvements provide immediate reinforcement for maintaining new outdoor habits. Sleep quality improvements happen quickly when you establish consistent morning light exposure. Your circadian rhythms start synchronizing with natural light cycles, making it easier to fall asleep at night and wake up refreshed in the morning. This improved sleep quality enhances memory consolidation and cognitive performance during daytime hours. The key to long-term success involves building sunlight exposure into your existing routines rather than creating entirely new habits. Morning coffee outside, walking meetings, outdoor lunch breaks, and evening strolls become automatic parts of your day rather than additional tasks you need to remember. Seasonal adjustments help maintain consistent exposure year-round. Summer strategies might focus on early morning and evening exposure to avoid harsh midday sun. Winter approaches emphasize maximizing whatever daylight is available and using artificial light supplements when natural exposure is insufficient. Temperature considerations matter for sustainable outdoor exposure. Dressing appropriately for weather conditions allows you to spend time outside comfortably in various seasons. This might mean layered clothing in winter or seeking shade during summer heat while still maintaining outdoor light exposure. Rapid improvements in energy, mood, and cognitive function provide powerful motivation for maintaining sunlight exposure habits. Most people notice significant changes within the first month of consistent outdoor time. These improvements compound over time, creating better sleep, sharper thinking, and more stable mood patterns. Reclaiming your relationship with the sun represents the simplest and most powerful step you can take for long-term brain health. This approach costs nothing, requires no prescriptions, and provides benefits that extend far beyond vitamin D production. Your brain evolved to function optimally with regular sunlight exposure, and restoring this natural partnership creates the foundation for cognitive health that can last your entire lifetime. The question that remains is whether we'll recognize what we've done to ourselves before it's too late. Our modern lifestyle choices have created an unprecedented health crisis that affects over 1 billion people worldwide. We built climate-controlled environments, entertainment systems, and food delivery services that eliminate any reason to step outside. The result is 1.2 billion people with vitamin D deficiency and skyrocketing rates of dementia, depression, and cognitive decline. However, consistent sun exposure can reduce dementia risk by 15%, according to 2025 meta-analysis data. Here's your specific action plan. Get 15 minutes of morning sun exposure on your face and arms without sunscreen for vitamin D synthesis before applying SPF protection. Take your lunch break outdoors and walk midday when possible. If you can't get outside, SAD lamps at 10,000 lux for 20 minutes daily provide circadian benefits, but not full mitochondrial support, per Sehult's research. The sun has been humanity's most reliable health partner for millions of years. It's time to stop treating it like an enemy.